Hello guys, I'm doing a video on the Michaelis Menten versus the Lineweaver Burk plots. So starting off, let's look at the Michaelis Menten. So looking at Michaelis Menten, it is important to notice two things like initially. So it's this graph, which is important to be familiar with, and also this equation, which is important to memorize. Okay, now getting into it. Keep in mind that this point right here, every single Michaelis-Menten graph will have one, is going to be our Vmax. And the units for Vmax are concentration over time. Now, some people like to trick you with the units of concentration over time. For example, this can be in micromoles instead of millimoles, and this could be into minutes rather than seconds. So keep on the lookout for that. Next off, it is important to know that the lower the Km, so the lower that this value is, actually means that your enzyme will have more affinity towards your substrate. So low Km equals high affinity to the substrate. Now also keep in mind that Km is in units of substrate. It is this point right here. So it's not going to be substrate over time. It's just substrates, and it's in concentration. So it's going to be some type of molarity, like micromolarity, millimolarity. Now going into the Lineweaver-Burk plot. So it's important to know how the graph looks as well as this equation. So sometimes you won't know the equation, but you will know the Michaelis-Menten equation, which is this right over here. So how to get to the Lineweaver-Burk plots from the Michaelis-Menten is you write down this equation, but then you do the reciprocal of it. So you would do like 1 over all of this. So you'd flip this guy and this guy, and you'll end up with this. And once you simplify it a little bit more, it's still the same equation, by the way, you'll end up with something like this, which is in graph form. So it's y equals mx plus b. I would say one of the most important things about the Lineweaver-Burk plot is how do you calculate x or y? So if we look at this point right over here, we have an x value. But now, so we would put 1 over km equals negative x. Keep in mind that it's a negative x because it's on the negative side of the graph. So from there we can find our x. Also we can find our km if we're given our x, so keep that in mind. Also, now how are we going to calculate our y? So we look at this y graph and we're going to pick this point right here. And this is going to be 1 over Vmax. And from there, if we have our Vmax, we can get our y. If we have our y, we can get our Vmax. And finally, we have the slope of Km over Vmax, which is going to be this guy divided by this guy. So if this is on top, this is going to stay constant. So it's going to look like, it's going to look a little bit like 1 over Vmax divided by our x, which is 1 over Km, which is going to result in Km over Vmax, which is going to be our slope.